because it's right here. It's right here all around us. Once you can make things so much smaller, it changes the world in ways we can't anticipate.
I know my research is going well when I'm surprised by what I see. That's when we find something new. It's about fundamental discovery about new types of matter, new ways that light, electrons, mechanical forces interact with matter.
Every aspect of energy storage, energy generation, energy transformation comes from the nanoscale. If I look at leaves, they're green because they reflect green light. They don't absorb green light. What leaves absorb is red light and UV light. So can I take all that green light and convert it into red light? It turns out you can. You just need these little things called quantum dots, and they can absorb the light and glow back the red color, so that in a cloudy climate, you can generate more useful light. That's a unique way of thinking and rethinking of what is arable land.
You can have a great idea in the lab, but that idea is a long way from having real-world or industrial impact. The nanocenter can really help us to bridge the gap between materials development in the lab and the type of reproducibility and understanding one will need to prototype a new engineered system, to even think about scaling those materials up to the levels where industry would become interested.
Seeing in biology has always been the key to understanding. One picture is not worth 1,000 words, it's worth 1,000,000 words. The ability to construct materials at a nanoscale, it's a very important new tool in cancer research. You can use them as imaging agents to tell you when the cell is changing from being a viable cell to a dying cell to a sick cell. And every time you can see something new, you can begin to use that image to understand the process and ultimately to take it to treatment.
Anything. It might be a glass, or a smartphone, or even a t-shirt. It doesn't really matter what. Now, think about what this thing does well. It could be holding water or chasing Pokemon, or if you're thinking about that t-shirt making you feel awesome. Then think about what it doesn't do so well, perhaps smashing when you drop it, or running out of power just when you need it. Or thinking about that t-shirt still, smelling of BO after you've worn it for a couple of days. It might not be obvious, but all of these things, the good stuff and the bad, depend on the individual atoms that make up the things around us, and importantly, how they're put together holds. How the different atoms in something are arranged can affect things like how strong or how weak it is, or if it conducts electricity, or if you can see through it, or even what it feels like. In fact, pretty much anything that the stuff around you does, it does because of how all the different atoms it's made of are put together. And this includes the things that you don't want stuff to do, like breaking, or smelling, or running out of power. If we were really smart, of course, we'd make the stuff around us work better simply by doing a better job of arranging the different atoms it's made of. And if we were smarter still, we could make totally new stuff by putting atoms together in ways that we'd never done before. We could even start to create stuff that behaves in quite unusual ways, because when you start playing around with atoms, you can tap into some really weird quantum physics. The trouble is, atoms are really small, more than 1,000,000 times smaller than the tip of your pinky finger, and that means they're not that easy to work with. But over the past few years, scientists and engineers have become increasingly good at designing and engineering materials down at the level of atoms or small groups of atoms. And because this new technology involves doing stuff at such a minute scale, it's called nanotechnology. Using their new skills, nanotechnologists are beginning to do cool stuff like creating materials that are really good at turning sunlight into energy, or using nanoscopically small particles to deliver anti-cancer drugs, or even turning polluted water into drinkable water. They're even finding new ways to make glass that doesn't break when you drop it, batteries that last longer, and even t-shirts that smell fresh after you've worn them for a few days. This is really powerful tech, It's helping us to do stuff we couldn't even dream of just a few years ago. But because nanotechnology is so powerful, we need to be really careful how we use it, just in case we end up causing more problems than we solve. The last thing we want is to make better solar cells that also destroy the environment, or design more efficient water filters that just happen to cause more pollution. Because of this, scientists and others are working.
One of the major global problems is waste of product, and a key reason why that happens is product can get stuck in containers, and there's no way to get this out. Associated with waste and dispensing, and so what LiquidGlide enables is complete dispensing of the product. That means you are not wasting product, which typically is around 5 to 20%, and because you are completely removed the product, recycling becomes easier. So we believe that LiquidGlide can completely eliminate waste and also provide a sustainable solution for both consumer packaging and a whole range of industrial products. LiquidGlide is a patented slippery coating that was invented in my group at MIT. It's really a concept where we can design the surface in a way that it could be slippery to a whole range of different liquids. So imagine this to be, we can make the coating entirely of the ingredients that are present in the food itself. We have developed a basic science-based algorithm that allows us to choose the solid and liquid combinations in a way that it can provide lubricity to the product. So it's incredible how we can cater the solid-liquid combinations of the coating to a given product. And so our vision really is to basically eliminate waste. So there should be no reason why we should waste product given LiquidGlide, and also friction reduction, which is again ubiquitous in many industries.
Sometimes when we take large materials and we make them smaller, for example, make them on the nanoscale, we find that the properties of those materials can be drastically different to what we expect. So one reason for this is the fact that as I take a material and I make it smaller, more of that material is actually available on the surface of that material than is available in the interior. We call this the surface to volume ratio. And if you think about why reactions happen and where they happen, interactions with light, with heat, with chemicals, they're going to happen on the surface first. And so by shrinking an object down to the nano size, I increase its surface area, and therefore I increase the amount of material that's available to react. The second thing that happens when I take objects down to about a billionth of a metre is that the forces that act on me at this point, so something like gravity that's keeping me on the ground, these forces actually become really unimportant when we get to small scale. And so what we find that happens is it's the forces and the interactions between the atoms and the molecules, so for example electromagnetic forces, or indeed something like thermal vibrations where the molecules and atoms are moving, these start to dominate on a small scale. And so we get a hugely different type of properties, and this is the reason that, for example, things like carbon can be very different in graphite to graphene. And this is why actually the nanoscale is probably one of the most interesting places in physics to be working.